Example: reduce the following equation to a canonical form and hence solve it. Y uxx plus x plus y uxy plus x uyy equals to 0. Now solution: the given partial differential equation is y uxx plus x plus y uxy plus x uyy equals to 0. Comparing equation 1 with the standard partial differential equation a uxx plus b uxy plus c uyy plus d ux plus e uy plus f u equals to g, we have a equals to y, b equals to x plus y, c equals to x, d equals to 0, e equals to 0, f equals to 0, and g equals to 0. Now the discriminant b square minus 4ac equals to bx plus y square minus 4 into a y and cx. So x square plus y square minus 4xy equals to x minus y whole square greater than 0. Since the discriminant is greater than 0, therefore the given partial differential equation is hyperbolic everywhere except along the line y equals to x, whereas on the line y equals to x it is a parabolic. When y not equals to x, the characteristics equation are dy over dx equals to b minus plus square root of b square minus 4ac upon 2a, which implies dy over dx equals to x plus y minus plus square root of b square is bx plus y whole square minus 4ac is 4 minus 4xy upon 2a's value is y, so equals to x plus y minus plus square root of x minus y whole square upon 2y, which implies dy over dx equals to x plus y minus plus x plus y upon 2y, which implies dy over dx equals to x plus y minus x minus y upon 2y equals to 1. Equation 2, d and dy over dx equals to x plus y plus x minus y over 2y equals to x upon y. Equation 3, integrating equation 2 and 3 we get y equals to x plus c1 from equation 2 and y square equals to x square plus c2 from equation 3, which implies c1 equals to y minus x and c2 equals to y square minus x square. Therefore the characteristics equations are xi equals to y minus x, eta equals to y square minus x square. These are the straight lines and a rectangular hyperbola. Now xi x equals to differentiation of xi with respect to x minus 1, xi x xx differentiation of xi x once again with respect to x equals to 0. Similarly xi y differentiation of xi with respect to y equals to 1, again differentiation of xi y with respect to y 1 is constant, so equals to 0. Similarly xi xy equals to xi x differentiation with respect to y minus 1 is constant, so equals to 0. Similarly eta x equals to minus 2x, again differentiation eta x equals to -2 and eta y equals to 2y. Similarly, eta y differentiation of eta y with respect to y equals to 2, and eta xy is in eta x differentiation with respect to y, where y containing term is not there, so equals to 0. So putting the value in a bar equals to a xi x square plus b into xi x xi y plus c into xi y square, b bar equals to 2a into xi x eta x plus b into xi x eta y plus xi y eta x plus 2c xi y eta y. C bar equals to a into c bar equals to a into n xi eta x square plus b eta x eta y plus c into eta y square. D bar equals to a xi xx plus b into xi xy plus c into xi yy plus d into xi x plus e into xi y, and e bar equals to a into eta xx plus b into eta xy plus c into eta yy plus d into eta x plus e into eta y. F bar equals to f and g bar equals to g. We have a bar equals to a plus y xi x square minus 1 square plus b equals to x plus y xi x xi y minus 1 and 1 plus c equals to x and xi y equals to 1 square. So which implies a bar equals to y minus 1 square equals to 1 minus in multiplying with x equals to minus x and minus 1 multiplying with y minus y plus x. So y to y cancel, x to x cancel equals to 0. Similarly, b bar equals to 2a xi x eta x. A 2a is y, eta x is xi x is minus 1, eta x is minus 2x plus b is x plus y into xi x eta y equals to minus 1 into 2y plus xi y eta x equals to 1 into minus 2x plus 2c xi y eta y. 2c equals to x and xi y equals to 1 and xi eta x eta y equals to 2y. So equals to 2 to the 4 xy plus x plus y into minus 2y minus 2x plus 2 to the 4 xy. So equals to 4xy minus 2xy minus 2x square minus 2y square minus 2xy plus 4xy equals to 2xy minus 2x square minus 2y square plus 2xy plus 2xy equals to 4xy. So equal, taking minus 2 common, x square plus y square minus 2xy. So x plus y square minus 2xy equals to x minus y whole square, so which is the value of b bar. Similarly, c bar equals to y into minus 2x square plus x plus y minus 2x plus 2y plus x into 2y square equals to 4x square minus x square y minus 4x square y plus 4xy square plus 4xy square equals to 0. D bar equals to y into d bar, their value xi x is 0. Similarly, x b equals to x plus y xi xy equals to also 0, and similarly c equals to x and xi yy equals to 0 and containing d and e terms is 0, so equals to 0. Similarly, e bar equals to y into minus 2 plus x plus y into 0 plus x into 2 plus 0 plus 0. Here a is y and eta xx equals to minus 2. B into eta xy, b is x plus y, eta xy is 0 plus c into eta yy, c is x and eta yy equals to 2 plus d term containing 0 and e term containing 0, so equals to minus 2y plus 2x. So taking 2 common, so 2 into x minus y, f bar equals to 0 and g bar equals to 0. Putting the values of a bar, b bar, c bar, d bar, e bar, f bar and g bar in a bar, u xi plus b bar, u xi eta plus c bar, u eta plus d bar, u xi plus e bar, u eta plus f bar, u plus g. We get 0 a bar because a bar equals to 0 minus b bar equals to 2 into x minus y whole square, u xi eta plus c is a bar is 0 plus d bar is 0 plus e bar equals to 2x minus y, u eta plus f bar equals to 0 equals to g bar equals to 0, so which implies minus 2x minus y square u xi eta plus 2 into x minus y into u eta equals to 0, which implies minus 2 xi square u xi eta plus 2 into minus xi u eta equals to 0 because xi equals to y minus x, so which implies xi square equals to u xi eta plus xi u eta equals to 0, which implies xi equals to u eta plus u eta equals to 0, which implies del over del xi xi del u over del eta equals to 0. Integrating we get xi del u over del eta equals to f eta, where f eta is a arbitrary function. Again, integrating with respect to eta, we get u equals to 1 upon xi integral of f eta d eta plus g xi, hence u equals to 1 upon, in place of xi y minus x, integral f eta place of y square minus x square plus d eta place of y square minus x square plus g xi y minus x is the general solution.